Hafaday, and welcome to this series about ancient sites and traditions of Micronesia. These episodes introduce the latest research and discussions about ancient life, history, and cultural traditions all across our diverse region of Micronesia. I hope that you like this series, and I look forward to learning more together.
One of the most famous ancient sites of Micronesia is the stonework complex of Nan Madol in Pohnpei. Among the most recent studies here, remote sensing techniques have documented the details of these stonework features and of the surrounding landscape, as presented here by Douglas Comer and Jacob Comer.
Jacob Comer and I, Jacob Comer himself, will be presenting on a LiDAR survey that we did at Nan Madol in the adjacent Timwin Island and the island of Pohnpei in Micronesia in 2019. And we think we discovered some very important landscape features. The actual instrument that we use during the survey is behind me. It's this one right here. So with that, Jake, do you want to take it away?
Really what we do is we specialize in applying remote sensing technologies to the management of protected areas, and particularly cultural World Heritage Sites. Nan Madol is in Pohnpei, in the Federated States of Micronesia. I have outlined Nan Madol in the map that you see here. It's down in the southeast of Pohnpei. The outlines that I chose are for the World Heritage Site. The orange is the outline of the buffer zone of the World Heritage Site, and the red is the core area. Nan Madol was inscribed to the World Heritage List in 2016. Nan Madol is so big and important and impressive that I find it hard to summarize. But one way of summarizing it very, very succinctly is to say that it's a complex of archaeological sites that together comprise a ritual and administrative center. It consists of about 100 islets, little islands that were made by people of basalt, stone, and coral. And these islets, at least now, are in the water for the most part. They're along the coast of one of the islets in the lagoon of Pohnpei, Timwin Island. So it's actually built on the top of a coral reef flat. Especially at high tide, there's water in between these different islets. It's pretty big. As I mentioned, it's really very impressive. It's about 3/4 of a square kilometer in area. We understand that it was built between about 1200 and 1600. And during that time, it was the seat of an island-wide political structure that extended its control over the entire island of Pohnpei. And the rulers of that political structure were called the Saudaliers. The different islets had different functions. It's understood that they had different functions. Some of them were residential. Some of them had economic functions like processing different plants, that sort of thing. Some of them had a ritual function. The Saudaliers, it's said, just for a little bit of context, the Saudaliers became increasingly despotic over time, increasingly tyrannical. So by the end of their rule, around 1600, they were overthrown by a certain Isokalekal. I'm really sorry for mispronouncing that. Isokalekal established the political system that it remains in place today, the Nan Marquis system. For the purposes of this presentation, I think it's helpful to consider that Nan Madol is not restricted to this area with the artificial islets. We talked about the fact that Nan Madol's right there. So it's built in the water on this coral reef flat. By the way, this is just a high resolution satellite image of the area. There are other elements, there are other spatial elements of what we can think of as maybe greater Nan Madol, or an area that's called Delir, hence Sao Delir, the Lord of Delir. This area around the core of Nan Madol, we can think of as Delir, or maybe greater Nan Madol. It includes these reef islets like Na Kap, Na Pali, and some of these areas on the mainland of Pohnpei Island. And then, of course, obviously, Timwin Island, the little island that Nan Madol is built right next to. So when we designed the survey, when we were thinking about doing this survey, we obviously were very interested in Nan Madol, but we wanted to be cognizant of the fact that Nan Madol had a larger area of influence than just that area, that 3/4 of a square kilometer area with the 100 artificial islets. For that reason, we designed the survey to cover all of Tenwin Island, in addition to the core area of Namdal. For a little bit of background on why we did it this way, we didn't originally design the survey purely for research. It was funded by the US State Department, which awarded our organization an Ambassadors Fund, an Ambassadors Fund for Cultural Preservation large grant. And the LiDAR survey was part of that project. And the purpose, the overall goal of that project was to write a sustainable conservation plan for the World Heritage Site. And there were obviously other elements of that sustainable conservation plan. We had an interpretive plan, we had a management plan, all those things. But for what we're talking about here, the LiDAR survey was really meant to have these conservation objectives above all. And some of those conservation objectives included, we wanted to assess the condition of Namdal's islets and structures. We wanted to identify some of the vegetation that was threatening the site. As you can even see in these satellite images, there's vegetation growing all over Namdal, in particular mangroves, and the mangrove roots are kind of pulling the stones apart, and then there's hibiscus and other plants, and causing damage to the stonework. And we also wanted to model the hydrology of Tenwin Island to better understand the process of siltation of the site's canals. So it rains a lot on Pohnpei, and the water flows off of Tenwin into Namdal and brings silt down. We wanted to understand that process a little bit better. So we surveyed almost 9 square kilometers in March of 2019. And where this takes us, now that we've talked about the conservation objectives of the survey, it kind of brings us to what LiDAR is and what it can do. And maybe the ways in which we hope to meet those objectives will become a little clearer after I talk about LiDAR a bit. Probably many of you already know a good deal about LiDAR, but just so that we're all on the same page, it refers to light detection and ranging. So the principle is basically the same as that of radar. So in radar, you have an instrument that shoots out these radar waves and basically measures how long they take to bounce back to the sensor. So LiDAR does that, but it uses pulses of light, little pulses of a laser instead of radio waves. So it emits these pulses of light, measures how long they take to return, basically. Here's a little island, maybe a Micronesian island, with some high vegetation on it. We got some low vegetation on this island, and then we have the ground. Okay, so that's what our island looks like. And let's imagine that we're doing a LiDAR survey. So we fly over it with an airplane with a LiDAR instrument on it. And the LiDAR instrument shoots out these laser pulses down at the ground. Keep in mind, we're just talking about a single laser pulse in our theoretical example here, but this is really happening if you're doing a real LiDAR survey. Probably around, a couple 100,000 times, tens to hundreds of thousands of times per second. Shoot down laser pulses. And on the way down, the laser pulse, part of the laser pulse might touch, this high tree. Some of it might kind of touch the low tree, and then some of it makes it to the ground. And each time it hits something, this laser pulse, some of that light will reflect back to the sensor. And what the sensor does is it records the function over time of that energy return. So here we see, okay, some of the light bounced off this high tree, all right? So you get a peak over here in our energy function. Some of it bounced off this low tree, so you get a peak here. And then a lot of it bounced up back off the ground. So you get this energy return function with these 3 local maxima. And then from that, you understand that there's something at this elevation, there's something at this elevation, and something at this elevation. So you get 3 different data points at 3 different elevations just from that single pulse of light, which is very nice. In practice, what does this look like? Okay, the main tomb complex at Namdal is called Nan Dewas, and I've just pulled a couple of pictures that we've taken together of Nan Dewas just to give you an idea of what it looks like in real life. This is the entrance, the main sort of portal to Nan Dewas. It's very impressive, obviously. I think those walls, I always forget exactly how high they are. They're like 20 feet high. This is one corner of it. You can see it's that beautiful stonework. This is what it looks like from a drone. We took this picture from a drone. This is what it looks like visually, right? This is what this really magnificent tomb complex looks like. So if you scan with a LiDAR sensor, it looks like this. This is one way of visualizing it. After you scan with a LiDAR sensor, you get these points. So remember, each time I said you get those energy peaks for the return function after you've shot those LiDAR pulses. For each of those peaks, you get a coordinate, a 3-dimensional coordinate, a point. And once you aggregate all those points from your LiDAR survey together, you get a data set that once you look at it like this, it kind of looks like a cloud of points. So we call those data sets point clouds. A point cloud is a set of these three-dimensional coordinates that you get from firing those pulses of light down and measuring the local maxima of the return function. What this yields you is a three-dimensional model of what you have surveyed. And from that point cloud data set, you can make other models that you can use for other things. For example, just a quick example, I took our point cloud of just the area around Nandawas, and really quickly, I just pulled everything that was not vegetation out of the point cloud. So that's what our image looks like on the left. If I take my data set and I say, okay, I just want to look at the points that touch vegetation, this is what we get on the left. And then I do the opposite on the right. I took the same data set and I say, okay, I want to get rid of all the points that are vegetation. And this is what it looks like. And you can see it looks like, it looks like Nandawas without any vegetation, which is very useful for archaeologists and a lot of other people, right? So this is an image that's derived from that point cloud that I mentioned for the whole survey area. And we just took the bottom of the point cloud, basically. What this image is doing is it's showing you something like the second figure on the last slide. I took all the vegetation away, and then I made a two-dimensional image of those remaining points. So basically, this image is what Temwin Island and Nan Madol would look like if you were to take all the vegetation away. As you can see, this is great because we see Nan Madol here with a lot of the vegetation removed. You can see the outlines of the islets and the wall around the site and all that sort of thing. There's Nandawas over there. But something that we didn't expect to see, but that we then did see, is that after you take the vegetation away digitally from Temwin Island, you see all of these changes on the landscape, all these sort of geometric looking figures. So suddenly it looks like Temwin Island has undergone a great deal of landscape alteration. This is just a zoomed in view of that same image. This is of the western part or a western part of Temwin Island. And you can see again all these sort of straight lines crossing each other, some lines that are kind of perpendicular to one another. So many of these things don't look like they're natural. They look like people have made them. And we've gone out into the field by now a couple of times to look around and see what these things really look like. And what we find basically is that there are these low areas. You see that there are these long, low areas that obviously water tends to collect in them. They alternate with raised areas, these kind of berm-like features that kind of run. They're longer than they are wide, and they run for meters and meters of distance. Some long features, again, that kind of look like water channels. I went there, again, it rains a lot on Pohnpei, so sometimes I've seen like right after it's raining, there's still a little bit of water running through some of these things, going downhill, for example. And on sloped areas, these terrace-like features, so it'll be kind of like flat, and then there'll be a much steeper slope for a short distance, and then it'll kind of flat again. And then, so you have these different features basically consist of people moving the earth around, modifying the landscape. Once we knew that they were there, we could go out on the ground, and with the help of the state HPO, cleared some of these things away with machetes and had a look at them. And that's what we saw. It doesn't look like these features are occurring in isolation, right? So it's not like you get like one berm, one raised area, and then it's totally separate from all the others and it's just out by itself, or, it's sort of destroyed by another one. It looks like, somebody kind of built one and then they built another one parallel with it, but they built a couple of berms and then made these channels to kind of bisect them at pretty regular intervals. The spatial layout might seem to suggest that there was a larger plan here. There was a larger organizational structure than just, people building berms, low areas, terraces, wherever. One might gather that perhaps there was a larger organizational scheme at work here. This is a view of, again, that western part of Temwin Island, and I sketched some things in the field, and this is what they look like after we can try to clean them up and put them on a computer. Terrace-like features, this is the profile view of this yellow line. Terrace-like features, and then this lower, this wasn't actually filled with water, it was just wetter, so I used the color blue. And then a berm on the other side from the terrace-like features. This is like a top-down view over here. So this is just a schematic of what some of these things look like. Here's a flyover. This is the version of the model with the vegetation digitally removed. We made this three-dimensional virtual flyover. You can appreciate in just a couple of minutes different angles on all these different landscape features. I said that there was an interpretive plan element to our sustainable conservation plan. And as part of that, we came up with the interpretive material that is in a new visitor center on Temwin Island, a new visitor center for Namdal. The visitor center isn't open yet, but when it does open, visitors will be able to see this three-dimensional flyover on a TV screen there. So they'll have some spatial appreciation for what it is that they're about to experience. So where does this leave us, the fact that we seem to see all of these landscape features? The most intuitively appealing interpretation is that these things maybe were used for agriculture. It kind of looks like an agricultural system, those berms, those terrace-like features, the low, wetter areas. Maybe it was even an agricultural system that was planned, like a spatially planned agriculture system. Again, like an overall organizational scheme and not just people growing things wherever. It's been hypothesized, of course, that Temwin supported a great deal of agricultural production in order to basically feed Nan Madol. Because Nan Madol is so big and it took so many labor hours to build, it must have taken so much effort to feed everybody there. It's been hypothesized that a lot of that food maybe came from Temwin Island or Delir, that greater Nan Madol area that we were talking about earlier. Above all, perhaps, it's going to take a lot more work to gather evidence relating to further information on these landscape modifications. For example, to figure out how old the features might be and how long they were in use, what exactly they were for, if they were agricultural, what crops were they for, and the context. What can these features tell us about, first of all, the relationship of Temwin Island and the immediate area of Nan Madol with the rest of Pohnpei, or of Pohnpei's relationship with other islands? Large-scale earthworks have obviously been documented and studied in various other parts of the Pacific. So just for example, over in Palau, modified ridge lines, lateral ditches, embankments, earth platforms. In New Caledonia, long raised horticultural mounds and house mounds. Vanuatu, range of linear mound features that in some cases extend for several hundred meters or form enclosures. Tonga is earthen fortification. Samoa, and then this is not even to mention the Solomon Islands and Hawaii. Some of these things sound pretty similar to what we're seeing on Temwin Island. We know that this is calling for a good deal of further work. A lot of field work would be nice, looking more into the oral histories, comparative analyses with satellite data that my father and I and some of our colleagues are working on that right now. And then again, I wanted to circle back to the conservation and management of Nan Madol. One of the things that we wanted to use the LiDAR data was for the vegetation management, right? To characterize the vegetation at the site. We identified areas for vegetation management with the help of some people who know a great deal about plants and vegetation management. I identified some priority areas for, I think, about a year now. This fantastic vegetation management team on Pohnpei has been going out and cutting back some of the mangroves and other plants that are really damaging the site in certain places. And the LiDAR helped us pick out some priority areas for that. The image on the left is of an islet called Pon Wee. The reason I included it here is because I'd never seen it like this before. I don't have a before picture, but we went and the vegetation management team had really cleaned it off and I was just blown away. This is a video that we took taking a boat through one of the main canals through Nan Madol. And this was another thing that I'd never seen before. So the vegetation management team has cut back a lot of these mangroves and opened this canal. The movement of the water is flushing some of the silt away, which is great. And you can also really appreciate all this incredible stonework that just goes on and on for hundreds of meters. In conclusion, this calls for a lot more work to be done. I think it's nice to keep in mind that this LiDAR data can be used for a lot of things. We really want it to be put to its best and highest uses for conservation and management and anything else really that it can be used for. This is a three-dimensional model that we had made of Nan Madol from the LiDAR data, again, obviously. And this is in the visitor center too. So when the visitor center is open, people will be able to go in and look at it and, see in 3 dimensions, what the site looks like.
Thank you for joining us in learning about ancient sites and traditions of Micronesia. If you would like to learn more details, then I encourage you to visit, in person or online, the Micronesian Area Research Center of the University of Guam. Thank you again for watching this program. I hope that you will continue to explore and discover more.